Okay, section 5.3 had a lot of vocabulary, so I wanted to kind of do a little comparison. So with theorem 5.6, the concurrency perpendicular bisectors theorem, and 5.7, concurrency of angle bisector theorem. So notice with the perpendicular bisectors, noted in red, I know that they are the perpendicular bisectors because it tells me that each side is congruent. So AY is congruent to YC, and it's also perpendicular to the line segment. So the point of concurrency for perpendicular bisectors is called circumcenter of the triangle. And the reason it's called circumcenter of the triangle, because all the angles, all the vertices of the triangle are equidistant at the point of concurrency. So we could take a circle and point P here would be the center of the circle. Now over here we have angle bisectors, so they are in red. So point P is our point of concurrency, and the point of concurrency of the angle bisectors is called the incenter of the triangle. Now notice that the segments that connect point P to the sides are all the same. They're all congruent. So if I were to draw a circle on this one, it would be inscribed inside of the triangle. So I want you to notice if we're talking about perpendicular bisectors, it's equidistant from the vertices. If we're talking about angle bisectors, it's equidistant from the side. And one last thing, the circumcenter of the triangle can be inside, outside, or on. So in an acute triangle, it is always going to be inside the triangle. In a right triangle, I don't know if you've noticed or not, but every time we found the circumcenter, it has been on the hypotenuse. In an obtuse triangle, that is going to connect outside of the triangle. So I know this is a lot of vocabulary, and that's going to be half the battle, is just remembering what all of the words mean. When we have our quiz next week, I'm not going to ask you to give me the definition of something, but you're going to need to know what the words mean in order to do what I ask.